basically going to be help us at the time. These are the two different classes we have. So you have to be stick with the loss most probably. I would also prefer the loss at the time of I'm going to do any kind of the task with regarding the classification task. So accuracy will be helpful some of the cases, like whenever you do some tabular data kind of the thing. And evaluation with respect to the trained data set and also the test data set. We will also see something related to the TensorFlow and early stopping results. Along with, we can also go with some other different data set like CIFAR data set. Okay, so yeah, this is some plotting kind of the nature. We already discussed somewhat overfitting with respect to the you can say trained results and also the test results. I think these orange points are representing as a train and this blue and green point represented as a validation. Okay, so let's also plot maybe the loss with EPOPs, loss with accuracy results. So somewhat overfitting, obviously, and somewhat overfitting with regarding the loss also. Yeah, let's also draw with other model. This is the fourth model we came across. Yesterday we have seen three models. So let's also plot with some other models like fifth model. So here we are just taking as a three layers, three convolutional layers. Just now we taken in the fourth model for the two convolutional layer. And also I'm taking max pool layer here. We already discussed, right? Max pool is going to take the maximum value with each corresponding to the region we are going to be specified. So currently we are just specified with the max pool size 2. Whoever having the size 2 max pool, it's going to be get that reduce the number of the sizes. Yeah. So conventional 2D along with the max pool, conventional 2D max pool like that. So we're taking the three conventional layers with sigmoid activation function at the end. This basically divided into the binary class classification. So these are all hidden layers, I can say, up to this. So flatten is going to be flattened the value to get the array value. Yeah, same thing will happen. You have to be check only the results, nothing else. So loss results with comparable with respect to the, yeah, it will be matched somehow. You can see it will be matched with regarding the three convolutional layer with max pooling. But unfortunately, what will happen? Accuracy is not satisfied. Accuracy is not satisfied. 85 is fine, but at the end you're required to get good number of accuracy results, right? So I mean, pointedness may not be acceptable to the end user or to any stakeholders. They required minimum of 9.5 results or 95% of the accurate results or the above maybe. So for that you have to tune further so that you will be get some more ideas integrated with this. So you can see somewhat fittingness with the second epoch or third epoch with respect to the accuracy and also the loss. So yeah, we have already seen this image data generated yesterday, some kind of the steering and also the rotation, zooming, blurring, and also the width shifting range and also the height shifting range. These are some hacks I can say. Whenever generating some new data with corresponding to the existing data, you can do some of the different hacks like this. So these are not only these hacks, you can also play around with the different hacks. You can, if you go to the documentation, you will find so many number of the hacks corresponding to the image data generated. So yeah, so rescaling again, because these are the new images, you can do the same process whatever we had done in the existing images, and then train according to that, attach it to that. I mean, adding to the existing whatever the images you have, just attach and train again. Then let's see, maybe the model 6 will going to be get the good results or not after attaching the data loader. So same thing happened with respect to the whatever we seen to get the accuracy results, but accuracy results are may not be satisfied at the time. Let's see how does that going to be works out. It's slightly going to be lower. You can see it's slightly going to be lower for trained data set, but validation data set is slightly going to be upper. So why this going to be happen? Why the our model going not going to be good results with respect to that? So something called as a shifting, data shifting. So we are doing, if you know some, you can say pack cards. So the pack cards is going to be helpful like a shuffling, right? Whenever you play these pack cards, you're going to be shuffled at the time while, I mean, before the game, right? So shuffling will going to be help us to randomly shuffle. Similarly, in this case also, the few of the images I will shuffle, because what will happen if you don't shuffle, the training data sets consist of the you can say training data sets consist of the same images, like existing images what we have before data generator. And what will happen, all the data is concatenated with the test data sets. So this is the reason we are not getting the good results for the training data sets, and we are getting the good results for the testing data sets. We need to shuffle. For that we have a function, actually you can see. For that we have a function with respect to shuffle. We can make it as a false, so that we'll get some idea. Yeah, you can see here. So shuffle is equal to 2. So we're just shuffling the data, so that we'll try to understand with respect to the images going to be shuffled with the trained data sets and also the test data sets. So the model 7, same implementation, whatever we have done with respect to the model 5, just corresponding to understand that. So we are just shuffling out. You can see somehow the much good results when compared to model 6. So the loss having quietly less, but it's okay. And similarly the validation loss, same thing will happen, and accuracy also somewhat decreases, and the validation loss is also somewhat slightly